Hello, this is Scholar Strife doing some math today in geometry, starting the first chapter of our book here, 1.1. And I think I've already said this before, but vocabulary is a huge thing in geometry. And what also is another big thing is how you draw and name things. So let's start on that. So a point has no dimension. You can make it as big or small as you want. We relatively, put a smaller dot than a big dot. And and we just call it point A or point B. If you wrote it out, point A. A line has one dimension. It is represented by a line with an arrowhead on each end. So I got an arrow here and an arrowhead on there. Normally a line consists of 2 points. Sometimes it doesn't have to. So here's A and B. So this would be called line AB. And we would draw the line above it. So this would be, one way to see it is line AB. So that's its label. A plane. This is kind of harder to describe, but it has 2 dimensions. It's kind of like a piece of paper. But a plane can extend out infinitely. So if you look at your wall and just imagine it extending out forever and ever. So one of your walls would be a particular plane. Your ceiling would be its own plane. The floor would be a plane. We're not, and once again, this is not talking about the airplane. Airplane's just a thing that, transportation. But your piece of paper is a plane. Your tablet or your monitor is its own plane. Just X and Y. And we just say, when naming a plane, we call it, usually they have a capital letter in the corner. So this would be plane G. Line or segment. A line segment. So a line segment is made up of 2 endpoints. I use 2 different letters this time, C and D. So you have one endpoint, you have another endpoint, C and D. So we label this CD with just a line over it. That means line segment. Okay, so once again, line AB has the arrowhead line above it. CD has a segment. Array has a start point. They call it an end point, but I like to think of it as a start point, and it goes on into a different direction forever and ever and ever. So let's call this EF. So this would be EF with 1 arrowhead. So a line goes in 2 directions forever and ever and ever. Segment has 2 endpoints, and it's stop. They stop there. Array goes in 1 direction forever and ever and ever. Okay. So when I converted this document, some of the symbols are off. So if you see this really tiny arrowhead here, that's supposed to be above LN. So I give 2 other names for the line LN. Okay. we can use... So if we're looking at the line LN, that's this one here. Okay. Now, we can use LN. We can use NL. So we can go backwards. We can use line B. So sometimes they have a lowercase letter next to the line, and that represents the entire line. So line B. We can also use other points on the same line. So I can say LM, and then it's reverse ML. I can use MN or NM. And all of those are the same line. Okay. Give another name for plane Z. So plane Z is this entire area on this sheet of paper. So this paper here. So that's that entire plane. So another way of naming planes is to choose 3 points on that plane. So I can say plane PML. P right here, M, L. And what's important when you're naming these, you can't just choose any 3 letters on the plane. You have to choose 3 letters not on the same line. Okay? And that means not collinear. So collinear, so name 3 points that are collinear. So collinear means on the same line. So for part C, L, M, N. So when we're naming points, we just say the letter. Nothing special. No dots, no nothing. So L, M, N. They're all on the same line. Okay. Notice. Oops. Okay, cleaning up my picture a little bit. So you notice that little a represents the line that's going through the plane Z. So A is not a point. It is represents the line, that vertical line there, not a diagonal. However you want to look at it. Okay. So our only 3 points that are collinear or on the same line is L, M, and N. There's no other collinear points. So name 4 points that are coplanar. So coplanar means same plane. Usually the key word or the key part of the word is co. Co means like together. So coplanar means together on the same plane. Collinear means together on the same line. So we're going to choose 4 points that are on the same plane. So if we look at plane Z, L, M, N, and P. So L, comma, M, comma, N, comma, P. Alright. So using the diagram from example 1, give 2 other names for the line MQ. So MQ, we can call it line A, or we can call it QM. And remember, when you're naming lines, you either use the word, or you put the arrowhead above. Okay. Okay, part B, name a point that is not coplanar, so not on the same plane with L, N, and P. So L, N, and P are on the z-plane, but as you can see, Q is not. Q, you could consider Q to be like above. Alright. Give another name for the segment Vx. You could just say XV. And that's all we can do. Because a segment has two endpoints, so that means you just have to reverse it if you wanted to do another name. Part B. Name all rays with endpoint W. So I'm going to redraw the picture really quick. So Y. So Y is here. W is here. V was here. X was here. And then we had Z. So name all rays with endpoint W. So rays, remember, are, they say endpoint, but I like to think of it as a start point. So we start at W, and we can go in the direction of X. We can go in the direction of Y, direction of Z, or the direction of V. Okay. So which of the rays from B are opposite rays? So opposite rays means they start from the same location, but they go in opposite directions. So for example, WX and WV. One's going to the right, one's going to the left. Same thing with WY and WZ. WY, WZ, up and down. Okay. So using the same diagram, another name for segment WY is, or YW is WY. Don't forget the bar above it. Okay, they're asking, are the ray VX and XV the same ray? No, because they're going in different directions. See, the ray VX starts at V and goes in the direction of X forever and ever. XV starts in the direction of X and goes in the direction of V forever and ever and ever. And then our VW and VX, the rays, the same ray. VW and VX, yes. Because it's the same line. They both start at V, and they both go in the same direction. Same direction. Same start point. Alright, sketch two different lines that intersect a plane at different points. So let's say we have our piece of paper. Let's just have this line. And this line. Let's say it hits the plane with this line here and this line here. That's one way to look at it. Kind of think of a piece of paper and you're holding like two pencils, and then you crisscross them onto the sheet of paper. They're touching the paper at two different points, right? Alright, part B. So the diagram to the right, name the intersection of line MX and line A. So we look at line MX. So you can see it's lined up with the gray there, the gray plane, plane C. And it intersects line A at point M. Point M. Two lines, if they intersect at a point. So two lines intersect always at a point. Well, they don't always have to intersect, but if they do intersect, it's always at a point. So in the diagram, name this intersection of plane C and plane D. So you put those two papers, so the gray where it overlaps with the white, so plane C and plane D, it intercepts at line A. So two planes intersect at a line. And that's the only way we can label this line. We can't say AM because A is not a point. So when you're naming lines, you always have to use 2 points, or if they have this little symbol off to the side, you can use that and say line A. Okay, that is all about section 1.1. Remember this vocabulary. You're gonna use it a lot. Make sure you know how to label planes, label lines, draw rays. Know what a plane is, know what a point line. A point has 0 dimensions, line has 1 dimension, a plane has 2 dimensions. Alright, have a good day.